Today we are going to go over our last lesson in chapter 4, the arc length formula. So there are two types of formulas we need to remember. The first case, given a function in the xy coordinates, for example, y equals f of x or x equals f of y. We have two formulas. So the arc length is given by from a to b. X is from a to b. Square root of 1 plus y prime squared, a to b. 1 plus y prime squared dx. Don't forget to take the derivative here. Similarly, if you want to integrate along the y direction, from c to d, 1 plus g prime of y, you have to change the function in terms of y here. Sometimes you can choose whatever is easier for you. Also, we have a formula for the parametric equation. So let's have a look at example 1 to example 3. So example 1, find the arc length of the graph y equals ln absolute value of cosine of x from 0 to power 4. You don't have to sketch the graph. You can directly apply the formula 0 to power 4. Square root of 1 plus y prime. So the derivative of y, which the derivative is given by 1 over cosine of x times the derivative of cosine give you negative sign. And then squared dx. So the absolute value here doesn't really matter because we have a square outside. And then you can evaluate this one from 0 to power 4, square root of 1 plus tangent squared dx equals 0 to power 4 secant x dx. Example 2, given function. Find the arc length from 0 to 8. So the arc length is given by 1 to 5, a function of dy. In this case, we are going to integrate along the y direction. X equals square root of y minus 1 cubed equals y minus 1 to 3 over 2. So this case will be square root of 1 plus x prime squared. Give us 1 to 5, square root of 1 plus x prime. Give us 3 over 2 times y minus 1 to the 1/2. Times the derivative of y minus 1 give us 1, the chain rule, so dy. So if we integrate this way, it will be so much easier to solve without calculator. So on the test, you have to choose the right one. Without calculator, if you solve it using dx, probably will be so hard to solve it. It's 9 over 4, y minus 1 dy. Then you can use u substitution to solve this problem. Example number 3. So given this, find the perimeter of the shaded region. If you look at the perimeter, we have 3 pieces. I'll call it A, B, C. L1, L2, and L3. So we have to find each of the length. So L1 will be integration from 0 to 2. Square root of 1 plus y prime, which is 2x squared dx. L2, which is, you don't have to use any formula, you can use the Pythagorean theorem. So square root of 3 squared plus 4 squared equals 5. And L3, distance from A to point C equals 5. So the perimeter equals L1 plus L2 plus L3. You just add all the values here. So the second type of arc length formula is given by the parametric equation. So for example, given x is a function of t and y is also a function of t. In this case, how do we find the arc length? The arc length is given by integration from a to b, x prime squared plus y prime squared. Both x and y are function of t, dt here. Let me show you some examples. Given x is the function of t, y equals a function of t, find the arc length between 0 to 2 pi. The arc length is given by 0 to 2 pi, square root of x prime squared plus y prime squared dt, which is integration 0 to 2 pi sine squared plus cosine squared as we know, sine squared plus cosine squared equals 1. So 0 to 2 pi, 1 dt. So it's t 0 to pi, so the answer will be 2 pi. Given this x and y, as we know, this is a circle. Center at 0, 0 with radius equals 1. The circumference, 2 pi times r, which is 2 pi, which we just proved. Let's look at the next one. Given x equals this, y equals this, find the arc length between these 2 points. Keep in mind these 2 points are x, y values. So from these two, we have to solve for t first. So we set 1 equals t1 and 1 equals t1 cubed. From here, use the first point, we solve t1 equals 1. Use the second point, x equals t squared, 8 equals t cubed. We solve for t2, which is 2. So our integration will be from 1 to 2, square root of x derivative squared plus derivative of y squared dt. Sometimes we have to use our calculator to evaluate the final answer. Okay, everybody, you can practice the following 3 problems and compare your answer with mine.